Ruby. So I basically try to recreate the Pokemon Ruby game as much as I could in Ruby. I got a fair decent away. And I skipped the introduction, but like, if I can, this is just what he ends up with. You can move through the map and then load more maps, and then different stuff happens and you play throughout the game. And he basically does all of the tutorial level of Pokemon Ruby. Yeah, so I just wanted to go through mainly how I got the map to work. So different images of the different maps. And then first things first, so to print the map, I've got a base class, parent class, that prints the map, and it just goes through for every row, for every letter, it prints it. And then based on the letters, it prints different stuff. So this is just the actual code for it. And then if you look at a map, this is what it is. It's just a huge two-dimensional array, and every letter corresponds to something on that map that you want to get printed. So all the T's, I don't know. Yeah, so all the T's, for example, turn out to be the pretty little trees. And that's all printed with emojis, which you can just do on the terminal, which I thought was really cool because it saved it from being lots of different block colors. And yeah. As you move through the map, there's a couple of things that you had to figure out. So you've got to place the character position, and then you've got to get input to figure out where they want to go. And you've got to validate the input so that they don't go off the map, or they don't walk into a tree, or they don't walk through a wall or anything like that. And you've got to remember what they're walking into, because when they walk away from it, you've got to replace it on the map. And obviously you've got to update the map and print the map and just do that all in a loop. So there was actually a couple of steps to this. All right. So the player position. So as we went through before, each map has a two-dimensional array that contains all the map's information, which was this little thing here. And then because it's a two-dimensional array, basically it turns out very easily that you can just use it as an X and Y coordinate to access any specific element within the array. So it translates very nicely to a map because it's just X and Y coordinates. So when the map is initialized, you load the map array, and then you overwrite a specific element where you want the player to be. So at the array of X, Y, you insert the player's icon. And then depending on the map, you can do that a number of different ways. And there are a couple of different ways I've done it here. So on this very left one, the van, it's the most simple map I made. And it only takes the player, and then it's hard coded where the player is going to be, because they only spawn in one spot. So you don't need to pass in the variable for them to spawn. In the middle, I've got their position. So you can pass in a top, or because it's only two, it's top or else, which is top or bottom. So they either come from the top or the bottom of the map, and they spawn there, and that's hard coded with the positions. And then on the right, with the little root, there's 5 different spots the player can come from, depending on which house they come from. And because of that, I just passed in the X and Y coordinates as an argument. So you can do it a couple of different ways, depending on the need. And yeah, so once you've got the player positioned on the map, you've got to get the player's input as to where they want to go. And this was very easy to do with just a simple loop. The only thing I found that was cool, when you did this, so I've got button equals standard dot getch. I don't know how you say that, getch. And that just means that you don't have to press enter every time you type a character. So it'll take everything you enter in as you enter in each character without you having to actually press enter. So it just saved a lot of time. And then when you, so for example, ASDW, so when you move right with D, it'll take you to the move direction. And when right, you take a look at, because you want to move right, so you're moving on the y-axis, 1 across, which is the position y plus 1, and you're trying to figure out what's there at that spot, and is it allowed to go through. So there are only 4 things that you can move through: grass, flowers, chair, and grey space. And then it's just checking to see if that element is where you want to move to. And if it is, then it'll be a valid movement. And if it's a valid movement, it'll update the position of the player. So then the player will actually move across. And if it's not a valid movement, the map still refreshes. So it still sort of has the feel as if you're trying to move somewhere. And then, as we said before, you've got to save the old variable of where you're going. So that, I've got a little example here. If the map was tree, player, grass, and the player moves right, then the map becomes tree, player, player. So you've got to replace the initial player with whatever was there before. So you've got to resave the old variable to recreate the map and then update the player's position again. So that every time the player moves, the map basically resets to its initial values, and then you find the new player's position and updates it. So this is what I've got just at the start of that move function. You take the current values of X and Y and make it equivalent to old X, old Y. And then you put in the map at old X, old Y, aka where you are currently, what the saved variable is. And then you move the player to the new position, and that's where they are. And then what you're moving into becomes a saved variable for when you move again. And then you just update the map and print the map, which happens after all the directions. So I've just closed all the code for checking when up and down. So the overview, when you move, you update the old X, old Y positions to get the previous map state. Then you move and update your current player's position, and you print the map again. And then the only other consideration really is when you want to go to a new map. So I've got this figure here. So on this map, you want to move, and this is the moving van. So you want to move out of the moving van to a new map, which is indicated by the absence of the blue lines on the right. So if you want to move at the right location, in the right direction, you go to a new map. And this is what the code looks like for that. So in the map array, the exit is indicated by the E. And then when you're checking to see if you're moving there, in the child, which is the individual map, which inherits all those lovely functions in the main parent map class, you've just written a little bit of extra code, which is in the move function, which you can't see my own mouse, so you can't see it either. At the very bottom, where it says def move, which overwrites the parent move. So if direction is moving right and you're at the E position, if you would move right, then you load a new map instead. Otherwise, you go back to the normal map functions, which is what the super map method is for. And that's just how it loads a new map. And then, as I was saying, for this specific map, Little Root, the hometown, there's three different times you can spawn and what different stuff happens each time. And there's different locations you can come from. So we've covered different locations, and now we'll cover different times. So for example, the first time you're in Little Root, the player's mum comes out and just talks to you, and you follow her into your new home. And then on the second time, you're not allowed past the guard to the bushes at the top. And then on the third time, you're allowed past, but you have to talk to the guard. So instead of recreating the map and retyping the array all over again, I made a little function called time setup, which updates the map specific to your current player's time that you've been there. And that's through the player class. So in the players class, at the very bottom, when you initialize it, I've got at little root equals first. So that loads little root with player or first time. And then every time you do a specific action, I think I already reset that. Every time you do a specific action, you update the variable. So for example, here we are. So you update the variable and you go, okay, at player dot little root map equals second or equals third or something. And that happens when you've done the particular objective that will update that map. So when you've done the thing, talk to the guy, finish it underworld, gain the magic sword, slain the dragon, or in this case, chosen your Pokemon. And then based on that, which we go back here, based on that, when you load the map, I've got this little time setup function. So you go, okay, player at little root. If it's second time, you place the little boy on the map, which is this little map up here, and it's the top left one. That little boy is there for the second and third times, but the second time he'll stop you from going out, and the third time he'll talk to you and then basically kick you out of the map. And that only happens when you're there for the second, because it puts him on the map when you load that. And then same for when you're moving, it'll check to see if the current player is little root value is second. And if it is second, you're trying to go up past that specific spot, it'll do a whole line of dialogue that tells you you can't go out there yet because you don't have a Pokemon. So basically it just forces you to play through the storyline as is intended. And then the only other thing is just dynamic play. So when you choose your character, you set your gender and your name, and it just stores them as variables. And based on your gender, it'll change your little display avatar, and it'll change the Professor Birch's kid to be the opposite of you. So it'll either be a little boy or a little girl, depending if you're a little boy or a little girl. And then just very briefly, that was challenging, but it was okay to work it. But when I was looking at like the actual further complications of what goes on in Pokemon behind the scenes, they've got this whole thing here. So when you calculate damage, it's this whole equation, and then it takes into effect all these different things. So the level, the critical hit, if it's attack, what type of attack it is, what power it is, the modifier depends on if it's a grass type attacking an earth type, attacking a water type, all of that. And it's not something that's overly complicated, and I don't think I could do, but it is something that I took as, okay, there's a whole lot of time that went into this. Even after you got all these calculated for you, you just got to implement it. To do that, it's an enormous undertaking. And it's just sort of something I really just learned and appreciated a lot doing it. And yeah, that's the whole little thing. So an example of that is this one. When you go through, you can't leave yet because you haven't gone upstairs. You go upstairs and you come down, and it's a different sort of scenario. You're forced to walk over to mum and listen to a little speech. And yeah, that's it, guys. Any questions?
That is very cool.
Yeah. And then I was also saying, like, if you try to go down, but it won't let you, but it'll still refresh the map to like visually let you know you're just trying to. And yeah, you do different stuff, and different stuff happens depending on where you are in the storyline.
And is it after that move method is called when you do you check if there's any talking that needs to happen or something else that needs to happen?
Yeah, so for the individual map, let's actually show you the code, which, okay, with that. So for the individual map, so when you go up to that little boy and you do the little thing, if you're the second time, so the first time you load and you talk to mum, you go into the house, and the second time you go through and you're supposed to go to Professor Birch's house. But if you try to go out because it's the same map, and it's this thing here just adds a little bit of code to the map's super parents move, which is here. And it just adds this bit to it. So if it's the second time and you're trying to go up and you're at the right position, then you do the whole little boy animation move. Boy talks to you, boy tells you to go away, you move down, and then it's back to you. So yeah, I hope that made sense.
How much of the game did you remake?
Just the beginning level, and then you got to choose your Pokemon and do your very first basic Pokemon battle, and then the game turns over.
Can we see one of the Pokemon battles? Do you have like a demo of it?
Yeah, sure. Sorry, I've got to play the whole game through because I don't have the save feature yet.
Thank you.
What did you use for those selections there?
It's a little gem. It's TTY prompt. And you should actually just look into it. It's very simple code to write because of the gem. And you just basically put in what your question is and then your choices. And then you just get to choose up and down.
Cool.
Does it all
Come across the TTUI gems before, but
yeah, TTY, they have a whole range of gems, and they sort of like, I use a couple for color, and I use one for the health for the Pokemon battle, which we will eventually get to.
Yeah, I've used one previously to run a process and be able to see the output of that process as it's happening, but also capture the output at the end of it.
Oh, okay. No, I don't think I've ever done that though. The one thing I couldn't get working, and I don't know if it's possible in Terminal just because of how Terminal works, is that I wanted to have like movement in the background while you could move, and I couldn't figure out a way to make it do it because the Terminal was always like waiting for your input before we update the map, which means it wouldn't do their input in the background. If that made sense. So yeah, I couldn't do like a little animation for someone moving around the map while you can also move.
I think you can still output while it's waiting for user input. You might just need to do it on a different thread.
Yeah, well, see, I don't think I've done threads, so that would be something I'd look into. Because that would be really cool. Yeah, you got to choose your little Pokemon. Go Torchic, fire. Yeah, now you can fight. Scratch. And basically, as all level 1 beginner Pokemon battles is rigged so that you basically can't lose because they do very little damage to you. Yeah, you can't run. Don't leave me.
Why can't you lose? Like they do some damage to you, right?
They do, like you can. I've got in that like you can lose eventually if you keep doing nothing to it but growling, which lowers their defense. But they do, because you're level 5 and they're level 2. The base damage is so high that you basically have to do this a whole lot of times before you lose.
You'd have to be trying to lose.
Yeah, you have to try to lose. And if you lose, I think I just may tell you that you aren't ready to be a trainer yet or something. You got to go do the whole thing again. But you did it. Finish the tutorial. Yeah, that's as far as I got.
Awesome. I noticed you have.
Sorry.
I
Sorry.
noticed you had Trevor as the name of the boy.
Yeah.
It's actually Brendan.
No,
which
because when
I
you go through, because I was playing alongside an emulator when I was building this, because
yeah.
frankly I didn't want to think too hard. I just wanted to like code as much as I could. And you get to choose, and what you choose, you have like you can enter your own name, but you can also just choose these preset names, and these preset names were the same as in the emulator for me.
I thought because my name's Brendan. When I restarted the game to see what starting it as a girl would be like, and the other character was then called Brendan. It was like, oh my god, does it pick up like what
Right.
name you used last time?
Yeah, so I don't have a name for the Professor Birch's kid yet. I just have their gender set to the opposite of yours.
Yeah.
So maybe they have a specific name, depends on what you are. I don't know.
Is Terry from something else then? Like different regions.
Yeah,
That
and
they
then
issued the game in.
room based on your preference, like all the random Pokemon trainers you encounter are like opposite genders most of the time. So I think like the Girl Scouts become Boy Scouts and stuff like that.
How long have you been working on this?
I did this in 2 or 3 weeks for my first assessment at Code Academy.
I think it was less than 2 weeks, Nathan. From memory.
Yeah, honestly it was a month or 2 ago, so I can't really remember.
I think you cheated and started slightly early, which I, conveniently forgot when marking it.
Yeah, because I did like the basic Hangman game. I was like, all right, now what? And you're like, well, that was your assessment, so go build a better one.
So how big is the whole code, How many lines?
The whole code. So everything up here is just the assessment. This is the actual code. So you've got all the maps. All the maps have their own little section, and they're all quite big, mainly because you've got the actual map, and then each one has their little variations of it. And then other than that, you got one for the battle, one for the player, and then a couple of different Pokemon. So I don't know, it's a couple of files, but not too many.
Yeah, I think it's at least 1,000 lines of code.
Oh yeah. So that's 100. But like this map alone is like 20 lines just for the map. And honestly, that was one of the most trying parts, because as you can see, like I started because I wanted to have, especially for my sanity, when I was trying to like copy the map onto code, I wanted it to be uniform, so I knew I had the X amount of rows correct. And then I added flowers at the end. I just couldn't be bothered, so I wrote flower.
Why not use emoji in the code there?
Sorry?
Why not use emoji in the code there?
Yes. So the emoji happens when you go through. You just do this. So this does the tree. T is the tree, and that's the emoji for it. I found that you find like the emoji universal code numbers online, and you put it in with a /U, and you put the number in there, and that creates the emoji. And then all these different ones. And honestly, the .colorize for emojis don't really work. I just put it in because I wanted some marks. And I found, to my frustration at the very, very end, you can copy paste the emoji as well, which would have saved me a lot of time doing all these / numbers.
I think that's what Brendan was referring
That's
to.
what I was asking, because he could have used that for the alignment in the.
Oh, I see. You're saying you should have just put it straight in the map.
Yeah.
Yeah.
I guess now I think about it, yes.
Make him cry. Just
You are making me cry.
I'm sorry.
been coding for 1.5 minutes when he did this. Like,
Yeah, this was the very first assessment.
Awesome.